welcome. In this lecture, I'm going to go through kind of a linear word problem example. I've already wrote the problem on the board. You can also, if it's a little difficult to read on here, you can read it in the notes there. But I kind of wanted to do this one by hand because I wanted to be able to draw the picture. I like to draw pictures. Okay, so we're in a situation where we have these three cities. We have Appleville, Orangeville, Bananaville. They lie on the same road. Okay. And it's 1 mile from Appleville to Orangeville and 2 miles from Orangeville to Bananaville. Okay. And then the story goes that most mornings I'm going to walk the 2 miles from Orangeville to Bananaville. Okay. So maybe I live in Orangeville. I walk 2 miles from Orangeville to Bananaville normally. But instead, maybe last night I was visiting a friend in Appleville and I need to get to Bananaville. Okay. And I'm going to walk at a rate of 3 miles per hour. And the question is, how long will it take me to reach Bananaville? Okay, and part of why I gave this particular problem is because intuitive, you know how long it takes. If I'm walking, what's 1 plus 2? So if I'm walking 3 miles and I'm walking at a rate of, and let's going to add my rate into here. So I'm walking at a rate of 3 miles per hour. So miles per hour, right? Then it's going to take me 1 hour. Okay, so let's actually write that down. And the reason why this is nice is often, and you can even do this for yourself, if a problem is too confusing, find an analogous simple problem where you know the answer intuitively and check your reasoning and see if you get the same output answer. I even do this sometimes. I'm not sure how to tackle something. So I look at a very special, circumstance that's much simpler. And I where I immediately my intuition knows what to do. And then I see if I can use that same technique. Okay, so here's the intuitive answer, right? Which was, as I said, we're going 3 miles at 3 miles per hour. So that should take me 1 hour, right? So, right, so traveling 3 miles at 3 miles per hour takes 1 hour. Okay. Now, let's do something that's more generalizable or flexible. I'll start this over here. Okay, so that's the intuitive way to do it, but let's do the generalizable or flexible approach. The generalizable or flexible approach. Okay, so the situation can be represented by an equation. Okay, so the situation can be represented. So it can be represented by this particular equation, and the equation is going to be y equals 3 x. So let's do, and this is going to be for your future. I'm going to make that red, just like I actually have it red up here. Okay, so 3x. Oh, this isn't the same one as that one. 3x minus 1. Actually, because that's confusing, if it's red, because you're going to think that it's red because of that. No, this is actually red for that one. Okay, there we go. Sorry. Where I'm going to have, so where we have, so our x. Oh, I wanted my x to be orange, though. That I did want to be true. The one tricky thing about this problem was because I wanted it to be intuitive, the 3 shows up in 2 different places. So that was why I, for a moment, wasn't sure that I wanted that like that. Okay, so where we have, so we have that x equals the time output, or the time passed, and then we have the y is going to be the distance past Orangeville. So y equals distance past Orangeville, right, which in our circumstance, we're going to want to be 2 miles, right? We want to go 2 miles past Orangeville. Okay, so let's graph this equation. So I have my y-axis, or sorry, my x-axis is my horizontal axis. My y-axis is going to be here. And then I guess I'm out of colors, but I'm going to just do this whole thing in red. Okay. So I've got y equals 3x minus 1. So y equals 3x minus 1. Okay, so this is this picture. So with that equation, so if we want to be, so if want to be, what do we want? We want to be 2 miles past, right? So this is the distance past Orangeville. So we want, right, looking up from here, I walk the 2 miles from Orangeville to work, okay? So if I want to be 2 miles past, so if I want to be 2 miles past Orangeville, right, then we substitute right, my y tells me my distance past Orangeville, so we need to substitute y equals 2 into my equation. So we want to substitute y equals 2 into this equation. And let's kind of do this. We can just kind of do this here. So I have y equals, and then I have 3, we'll go back to doing this blue because I want to use red for the entire thing there. So we have 3x minus 1. Right, so we want to put in this y equals 2 into there. So I have this y equals 2. I want that to go into here. Okay, so that just gives me that 2 is going to equal 3. And I know I'm solving for this x, right, because x is going to give me my time output. So x minus 1. Okay, and now we need to solve for the time output x, right? So, and I want to solve for the time output x. So solve for time output x, right? Because that's what I'm asking for, is when it says, how long will it take me to reach Bananaville? Okay, so I want to know how long it takes, so that's going to be my x. Okay, so then I've got, now I can just solve here. So I have moved, you know, I'm going to add 1 to both sides. So I'm going to get 2 plus 1 equals 3x. Right here I just, I added 1 to both sides. That was all I did. So added 1 to both sides. Okay, and now I just need to isolate x, so I need to divide both sides by 3. So I'm going to get, right, this here is 3. Right, this is 3. So I have 3 equals 3x, and now I'm going to get that x equals 1 by dividing both sides by 3. Okay, so in the next step, I'm going to divide both sides by 3. Okay, so I'm going to get that. So I have 3 equals 3x. I divide both sides by 3, and I'm going to get 1 equals x, or in other words, so i.e., I'm going to have that x equals 1 hour. And that's my final answer. Okay. And I want to say that this is kind of not a coincidence that there's this point on here. So I do actually have a point on this graph, which is 1, 2. Okay. So looking at what I have over there, right, the fact that I could have 2 as a y value and 1 as an x value at the same time does correspond to the fact that this is the graph of this equation. Okay, so not a coincidence, this point is on here. So not a coincidence. This point is on the graph. Okay, and we're going to kind of focus in on that kind of thing in the following lectures. But it's good to have this example in the back of your mind where you even kind of had intuition for what was going on. We knew we needed to go the 2 miles past Bananaville, okay? And the equation that's going to tell us if my input is the time it takes and my y is the distance passed. Oh, is the time, did I write output there? I meant to write the time input. This is an input. That would make more sense. Right, so the time that it takes to go, and then y is the distance past Orangeville, right? Then it's like I've got to have this rate 3 times the time, right? Because that's how you kind of get the distance gone. I have to have a -1 here because I'm actually starting in Appleville, okay? Which is 1 mile before Orangeville, okay? And then I'm going to get that, yeah, right, so this is going to be the equation that's going to represent that. 3 is coming from this rate that I'm going. I'm walking at a rate of 3 miles per hour. And then, so this is kind of like the distance that I've gone, but the first mile doesn't matter because that got me from Appleville to Orangeville. And I want to go past Orangeville to Bananaville, okay? And so I just I wanted to solve for, so I can put the 2 miles into here, and then I wanted to solve for my x. So I went ahead and did that and found it was indeed 1 hour. So I put the 2 in for y, and then I'm solving for x, right? Added 1 to both sides, divided both sides by 3. And then we kind of noted that this point where I have x equals 1 and y equals 2 does actually happen on the graph of this function because this, or of this equation, because this equation is actually the one that describes the circumstance. Okay, so I hope that made some sense, and I'll see you in the next lecture.